Okay, we're going to do a hypothesis test and confidence interval for differences between two population means when the population standard deviations are unknown. So it should be a plural there, and these standard deviations are unknown. All right, so two populations. There's no situation here. I'm just giving you the numbers to deal with. So from population one, we take a sample of size 49. We get a sample mean of 10 and a sample standard deviation of 3. From the population 2, we take a sample of size 64. We get a sample mean of 12 and a sample standard deviation of 4. And we're testing the claim that there is no difference between the population means, and we're using a significance level of 0.01. Now, since we don't know the population standard deviations, we're using a t-test or a t-distribution. This is going to be a t-test statistic. And our degrees of freedom, remember, one less than the smaller sample size. So our degree of freedom is going to be 48 here. Remember, in our tables, it jumps from 40 to 60. So we always use the lesser degree of freedom. So we're going to use 40 degrees of freedom when we get to that. So again, same 4 steps as always. Right? We go into the test thinking there is no difference between the two population means. Right? So you can either write this as mu1 equals mu2. I prefer this method where we say the difference between the two populations is 0. Against the alternative that it's not equal to 0. Right? It just says that there is no difference. It doesn't tell us to look for evidence that this mean is greater than this one or that this mean is greater than that one. It doesn't give us any side to look at. So it is a two-sided alternative. Our alpha level is 0.01. Remember, the two-sided alternative is going to come into play in step 3, where we have to double the probability that we look up in the table because we're looking at both ends of the tails of the distributions. So once we form the hypothesis, we go to step 2 and we form our t-test statistic. Right? This is the form of that test statistic. We went over that. The difference between the two sample means. Again, it doesn't matter which order you put it into, just be consistent once you make that choice. Don't say mu2 minus mu1 here and then x bar 1 minus x bar 2 there. Be consistent with your choice and keep track of what direction or what greater than 0 or less than 0 that you're looking at. Okay, so in this case, I formed the null hypothesis from population 1, population 2 as mu1 minus mu2. No difference. Mu1 minus mu2 does not equal 0, which says there is a difference, but we don't know what side. So we calculate that test statistic. The difference between sample mean 1 and sample mean 2 is going to be -2. Right? The numerator of this test statistic is -2. And when we calculate this denominator here, the standard deviation of the first sample was 3. 3 squared is 9 over 49. Standard deviation of the second sample was 4. 4 squared over 64. We calculate that number here in the denominator. You should get something very close to this if you're rounding. And then when you calculate your t statistic, remember a t statistic, the tables go to 1 decimal. So we're rounding our t statistic to 1 decimal. We get -3.0. All right, so the two-sided alternative, this is where that matters. When we go to step 3 and find the p-value, the probability of finding a difference this large, given that our null hypothesis is true and the data that we were given, the probability of finding a t-value more extreme than what we found, this is -3. So more extreme is less than -3. Our t-tables give probabilities to the right. Let's go look at that t-table and see where we're getting this number of 0.002 and then doubling it to get 0.004. So let's go to our t-table here. Here we go. Here we go. All right, so this is the T critical value. We'll use that when we do the confidence interval. But as we go down to our T table pages, remember each one has degrees of freedom across the top. First page here goes 1 to 12. For some reason I doubled that. The second page is exactly the same as the first page. Ignore that. But we want degrees of freedom 48. This page goes degrees of freedom from 13 to 24. The next page takes us where we want to be. 25 goes up to 40 and then jumps to 60. So remember we said ours is 48. And if we have to choose, we always choose the lesser degree of freedom number. So we're going to choose 40 degrees of freedom. And again, the table gives us probabilities to the right of the T that we're looking up. We want the probability to the left of -3. That's going to be the same, again, by symmetry, since 0 is in the middle here, and it's a symmetric distribution. If we look up the probability greater than +3, we will get the answer that we want, 40 degrees of freedom. When we go down to this column over to 3.0, over to 40 degrees of freedom, and we see 0, 0, 2. So that's our probability of getting a value less than -3 in this T distribution with 40 degrees of freedom. We double that value because it's a two-sided alternative. So we double that value of 0.002 to get our p-value of 0.004. Our conclusion, again, so remember what that says. That says if the null hypothesis is true, we're going to get a difference this large only 4 out of 1,000 times, right? So that leads us to believe, well, maybe the null hypothesis is not true. If this is only going to happen 4 out of 1,000 times, maybe my assumption is wrong, right? But we have a numerical way to measure this. We compare the p-value to alpha. Our p-value of 0.004 is still less, even if we double it. It's less than the alpha level of 0.01. So by that criteria, we reject the null hypothesis. We do have enough evidence to suggest the alternative, right? The alternative is that there is a difference between the two. Our evidence showed that we do have enough evidence to go with that alternative. If we conduct a 99%, or if we construct a 99% confidence interval for the difference between those two unknown population means, well, again, we have the formula for that, right? We have that formula. That is, where's my markers? We have that formula. It's this here. So we're plugging these numbers in. We already know the difference between our two sample means is -2. We use a T critical value here, 40 degrees of freedom, 99% confidence. So again, let's go look that up to make sure you know where you're looking here. For the T critical values, you go to this table here, this one, T critical values. We want 99% confidence, 40 degrees of freedom. So 40 degrees of freedom, 99% confidence gives us a T critical value of 2.7. Okay? For 99% confidence, that column, 40 degrees of freedom, that row meets up here at 2.7. So that's our T critical value. That's where we're getting this number. We've already calculated this value over here. That was the 0.6585. So we already have that. This is our margin of error, right? This is the center of our confidence interval. This is the margin of error. That margin of error comes out to 1.78. When we calculate the confidence interval, again, put the low number to the left, the high number to the right. -2 minus this number gives us -3.78. -2 plus this number gives us -0.22. So what I want you to notice here is that 0 is not in this interval, right? That agrees with our rejecting the null hypothesis at that same significance level. Significance level of 0.01 is the same as a 99% confidence level. So if you construct a 99% confidence level for that difference, and it doesn't include 0, that agrees with your conclusion that at an alpha level of 0.01, we do not have enough evidence to suggest that there's no difference. In fact, we have evidence to suggest that the difference between the population mean 1 minus population mean 2 is a negative number. If this is going to be a negative number, then that means this number is larger than this one. So we can come to that conclusion, right? Because if this is going to be negative, if this value is going to be negative, then this value has to be greater than that. And that kind of makes sense, right? This value is 12, the value is 10. It's not much of a difference, but the sample sizes are large enough to give us enough evidence and a p-value to reject that null hypothesis, and our 99% confidence interval agrees with that conclusion. All right, so that is an example of a hypothesis test and a confidence interval dealing with the difference between two means when the population standard deviations are unknown and we have to use the t-distribution and t-critical values. All right, good times.